Quantiles. This is a skill we have done before, so these will be familiar. And then we get over here, we've got just a little bit of problem solving, but with the same techniques. So we have x is some variable and it is normally distributed, follows the normal distribution, has a mean of 30 and a standard deviation of 5. Find k, find this number of k such that the probability of x being larger than k is 0.23. So if I'm going to draw this distribution, here's k, and I know it's this end, okay, because it only has an area of 0.23, so it's going to roughly look like that. Our mean is 30, so that means my number k is going to be larger than 30. I want to figure out what is this number k. So here's the instructions in our calculator. We're in menu, statistics, distribution, normal, and inverse normal. Okay, these are the options that pop up. Tail, area, standard deviation, mean. So bring that up. Now, we're going to look which way is the arrow pointing. Here it's pointing to the right, so my tail is right. My area is 0.23. Standard deviation and mean remain the same, 5 and 30. And that's all we need to solve this. And I've got k is 33.69. It'll be 33.7. And so then if I do a normal distribution calculation and I say, what's the probability of the random variable being more than 33.7? What's it going to be? 0.23. So it's the inverse calculation. That's why it's an inverse. All right, we've got probability of x being less than k. Now, I know this number k is also going to be above 30. All right, and the reason I know that is because with a normal distribution, we have 50% of the data on the left, 50% on the right. And so 0.65, that's more than 50%. So it's coming over this way. K is going to be here, and less than k is 0.65. So that's what it looks like visually. Let's go ahead and calculate it. Our tail is pointing to the left. Our area is 0.65. Standard deviation, mean. Determine the k value. $31.92. Okay, now when we have a question like this, the tail is going to be central. The area is 0.8. Standard deviation is 5, mean 30. Okay, and you get two values. I've got K1 and I've got K2. 36.4. Now, sorry, that's not K1. This value is the mean take K. Okay, the lower one is the mean take K, and the upper one is the mean plus K. All right. So here's the mean, and we're going up some value K and down some value K. It's symmetrical about that point, but the area between those 2 points is 80%. Now we just need to be careful here because we're not quite done. We need to say, what's the value of K that satisfies this? Well, we know the mean is 30, right? So that means if the mean plus K is 36.4 and the mean is 30, the value of K has to be 6.4. All right, we can get it from the mean plus K or the mean take K. All right, that value of K is going to satisfy both of those equations. We know the mean is 30. Okay, cool, next one. So this one involves just a little bit of problem solving. There's going to be a couple of these in the exercise. Now, here we have a distribution, mean of 50. So I've drawn the mean of 50 here and a standard deviation of 10. Now we're told the probability between 42 and A is 0.34. Find the value of A. So I'll just explain why I've sketched it the way I have. Here's the mean. 40 would be one standard deviation below the mean. Now we know from the normal distribution that 34% of the data occurs between 40 and 50. All right? Now this point is further to the right, so that means A has to be further to the right as well for it to have 32% of the data. Okay, now the way we're going to calculate this one is, there's two ways we can go to the right or to the left. Let's go to the left, okay? So if we're thinking about the left, right, what I'm going to do, I'll get another colour up here. Well, I want to say, what is the probability of this event? Okay? I want to say, what's the probability of this event? Because then I can say, well, the probability of A, of the variable being less than A, is going to be the sum of those two. So I want to know, what's the probability of the event being between minus infinity and 42? Okay, I'm calculating the shaded blue region. And we've got a standard deviation of 10 and a mean of 50. So I need to calculate that first. Alright, so my tail is pointing, it's a normal calculation. Distribution, normal NCD, minus infinity to 42. Standard deviation 10, mean 50. I've got 0.212. Okay, so let me try and illustrate really clearly the two distributions we've got here. All right, so we know that from 42 downwards, okay, we know that this area is 0.212, and we know that the area from 42 to A is 0.34. Okay, what can we conclude from this? That the probability of our variable being less than A is going to equal 0.212 plus 0.34. It's the sum of those. So what's that? 0.5552. Right? So we calculated this region and we know together they're going to give us a probability of x being less than A. And now this is just an inverse normal calculation. So we're inverse normal, our tail is pointing to the left. $10, 50. Left, 0.552. I've got 51. So I'll just explain one way we can confirm that. If you were to do the normal calculation between 42 and 51.3, you're going to get this answer 0.34. So what did we do there? We said, I want to know the area completely below that point, or you could have done above, but we've done below. And so now that I've calculated that area, I can make this statement. Probability of x being less than A, 0.552, and now I can solve that using inverse normal. So there's two parts to that. Most of your exercise will start like this, and then gets into some more complex problem solving. So a short one, that's all the plan for today, so let's get started.